What'd you get for the first one?
5.6 times 2 nearly.
We got some bell work. Ryan's going to do A for us. Looking at percent error, accepted value calculated mathematically, and then your error is calculated based on the experiment. You'll see this in college. They'll evaluate you. Oftentimes they have an accepted error they're looking for. So it's like 80 to 90%. Usually what the average is. That's an A. And if you get like a 60, it's like a C. You understand what I mean? Very rarely will it be 100%. They're looking for a specific range of what your error should fall into. So significant figures. Has anybody ever heard of significant figures before? Raise your hand. Okay. So significant figures relate to rounding a number. Because when you round a number, you're changing that number to a 0. So like here you've got 399. And then you're going to round it. Somebody says round at the hundreds place, you round it to 400. So these two zeros have been rounded. Does everybody see that? So you've changed the number. Now, did you count these two zeros? Adam, did you count those two zeros right here? No, you didn't count them. You rounded them. They were 9s, but now you've rounded them. Now, you have to have some way of telling the general population this. So if you put out 400 on your data, right? Well, did you count the 400 or did you round to 400? So there's got to be a way of doing that, and we use the decimal to do this. So very few things in science are counted like money. When you go to the bank, you'll always see a decimal. So you'll see like $400.00. The bank counts everything you deposit. It uses the decimal to show you that. So right here, it says this zero is counted, this zero is counted, this zero is counted, this zero is counted. This is the bank. You always want them to count your money. So here you have 1, 2, 3, 4, 5 significant figures. All whole numbers are significant because you didn't round them. So that means the 4, the 1, the 2, the 3, the 5, the 6, the 7, the 8, the 9, those are all true. So we're really talking about true numbers. These are all true. Now, let's go back to our initial example here. You got 399 and you rounded it to 400. So you just put 400 here. This is, let's say, counting beans we're getting ready to do. So you have 400. Do you see a decimal there? No. So how many true numbers do you see there? Actually, just one, because you rounded these. This would be a true number here. A true number is a number that's been counted. A true number is one that has been counted. Now I say true number because if I said significant figure, a lot that's flying over your head. You haven't heard it a lot, so you might think that's too complicated. Significant figure is a true number. Just another name for saying true number. So your only true number here is this 4. Why? Because you rounded it. It's not 399 anymore, it's 400. Now the question is, well, why would you want to round a number? What does rounding a number, why does rounding benefit science? Okay, let's look at just rounding this number from 399 to, well, we have to round up because of the 9 there. Let's stick with this example. If you say 400, how many chances of being correct do you have if you say 400? What could you round to get 400? What's your range? Do I know the range? So you got 450 to what? 350. You see the range here? This is called the range. That is, if a number falls within this, you're going to round up to 400. So that's the range. And that gives you a chance of being correct. You have 100 chances of being correct. Why you would want to do this? In science, we like to increase our chances of being correct. We want to win. And if you say one number that you only have one chance of winning, that's not good. So we always want to increase our chances of winning or being correct. Excellent job of calculating the paper clips in our box. And she took total mass 120.41 divided by one paper clip as 1.21. She got 99.5. Now, do you expect that there are 100 paper clips in that box? No. I would probably say there are how many? There are probably 99 paper clips in that box. So are you going to freak out and go to the company you bought these, whether it's Walmart or what's another place that sells paper clips? Staples. You know, you go there and you count out of the box 99. Let's say there are 99 paper clips in the box. It says on the label right here, it says on the label there are 100 paper clips in the box. So you go and you're complaining because there's only 99 in the box. You're freaking out. Say, I want my other paper clip. Now they're going to give you another paper clip. Now most people would. Like if you went into Walmart and you counted this out, you in a little row, and you kept the cashier. And the customer is always right. This says 100, and you go into the back, and you open another box, and you count it out, and they're 99. Then you start freaking out. I'm a lawsuit. So I'm gonna bring a lawsuit against you. You go talk to your lawyer. What's your lawyer gonna say?
Too bad.
What's the lawyer gonna say? No, the lawyer is gonna say, what is the range for 100, no decimal? Well, most people aren't. Most people don't pay attention in school, and then they wonder why, they wasted their money on a lawyer. So what's the range when you say 100? 50 to what? 50 to 150. So it can be anywhere between 50 and 150. They could have put 60 in there, and you would have been like out of luck. The lawsuit would not favor you. It would favor the company. So you can take advantage of people based on significant figures, but most people don't. Most people are ethical. It's going to be close to 100. So if it was 99, this is what saves them from frivolous lawsuits, understanding significant digits. Okay, so your total mass for all the paper clips, 120. And you've got 120 total mass divided by the one paper clip. And what's your total number of paper clips calculated to be?
Should I do which one?
Yeah, 120.46 divided by 1.20.
100.
Okay, so he calculated 100, right? Now, unfortunately, Alex counted the number of paper clips in the box. How many were in the box, Alex?
About 96.
97. I think you calculated 97, didn't you? You counted 97. Is that a problem? Because the box says 100, right? And he counted 97. Okay, so on your balance, there's a button on the balance called the 0 button. Everybody say 0.
0.
So what Claire's gonna do, before she puts anything on there, this is called a weighing dish, and it protects the balance. So often we put this on there first, and you'll see there's a mass there. Does everybody see that? So we want the balance to memorize that mass. So we hit the 0 button. And you'll see the balance goes to 0. So you can play this video tomorrow and you can see the balance is 0 if you can't see it back there. Now she's going to place the paper clip on the balance, and it gives us the mass for 1 paper clip. So you should write that on the board, just like we did for the beans. This is a conversion factor now. 1 paper clip weighs 1.21 grams. So you're going to want to write that 1 paper clip equals 1.21 grams.
I lost my count already.
Start over. We need an accurate count. It says there's 100 paper clips in the box.
Start over? Okay, ready, set, go. Mr. Z. No, Mr. Z. He came in with a little.